So in this problem, we're given a function f of t, which is t periodic. So in other words, f of t plus t is equal to f of t. So the most, of course, famous periodic functions are, example, we have f of t equal cosine beta t or sine beta t, and the period is 2 pi over beta. So the question now is to find Laplace, a formula for Laplace of f of t. But they are giving us the formula, which is 1 minus e minus ts, the integral from 0 to t, e minus st, f of t dt. So there are two ways we're going to do it. So the short way, which is to write that Laplace of f of t is the integral from 0 to plus infinity e minus st f of t dt, which is the integral from 0 to t e minus st f of t dt plus the integral from t to plus infinity e minus st f of t dt. So now we do a substitution plus, so we take x equal t minus t, so x here, we will put x equals t minus capital T. So we'll get that this is the integral from 0 to plus infinity e minus sx f of x plus t dx. And since f is periodic, f of x plus t is equal to f of x. So what we have here now is the integral from 0 to t e minus st f of t dt plus the integral from 0 to plus infinity e minus sx f of x dx. But since x is a dummy variable, this is exactly the Laplace of f of t. So we get Laplace of f of t equal 0 to t e minus st f of t dt plus Laplace of f of t. I think I forgot a term here, sorry. Yes, there was a mistake. The mistake is in here. It's not x, it's x plus t. Because t is equal to x plus t. So what we have is, so here, so we have the integral from 0 to plus infinity e minus sx e minus st f of x dx. And now we take e minus st, this term out, from the integral 0 to t e minus st f of t dt plus e minus st, the integral from 0 to plus infinity e minus sx f of x dx. And now we recognize here that this is the Laplace of f of t. So we have Laplace of f of t equal the integral from 0 to t e minus st f of t dt plus e minus st, the period, Laplace of f of t. So now if we do some algebra, we'll see that we have Laplace of f of t minus Laplace of f of t equal the integral from 0 to t e minus st f of t dt. And so this will give us e minus st Laplace of f of t equal the integral from 0 to t e minus st f of t dt. So this tells me that the Laplace of f of t is equal to 1 over 1 minus e minus st, the integral 0 to t e minus st f of t dt. So this gives us the formula that we're looking for. One assumption in this problem was that this function has a Laplace. Note, not all periodic functions do have Laplace. Like, for example, if you take f of t equals tangent of t, Laplace of f of t does not exist. And the reason why it does not exist is because of pi over 2. So at pi over 2, when we write the integral, the improper integral from 0 to plus infinity, pi over 2, because of tangent, will give us an improper behavior. There is a vertical asymptote at pi over 2, and the integral is divergent. So it doesn't matter what s, the value of s is, the improper integral will always be divergent.